Okay, upcoming assignment is on domain and range. And my open math and the text and everything will give you, camera looks crooked, I guess it's just me. Yep, okay. But we're going to illustrate the idea of domain and range with the basic, extended basic, and complete basic functions. Okay, the 5 basic functions. Well, I'm going to just start off with the basic squaring function because that's one everybody understands probably the best. But we should understand them all just as well as this basic squaring function. And if you can understand that function even better, then that's even better. Okay, so the domain of the basic squaring function. Now the domain of any of the basic functions consists of all the values, -2, -1, -1/2, 0, 1/2, 1, for which we can calculate the exact value, either as a fraction or a decimal. Okay? And for the squaring function, well, we can square any number at all. Okay, we can certainly square -2, we get 4. We can square 1/2, we get 1/4. Square 0, we get 0. And of course, we have a graph then that looks like it's the white points. Okay? The domain of the function is the set of all the values that we can use. And you know, I left copying this down. Inadvertently left 2 off here because I was, I guess, in a hurry. Okay, because we had to spend a lot of time talking about the quiz and other aspects. Okay, anyhow, there we have it. So, the domain is all those values. So we can, I've circled domain in blue, and I've marked the x values corresponding to the domain down here. -2, -1, -1/2, 0, 1/2, 1, and 2. That's what we mean by the domain. It's all the x values, a set of all possible x values. For the basic squaring function, the domain is restricted to all of these numbers for which we can exactly calculate the result. Okay, the range consists of all the y values. Well, we know from the basic squaring function that the y values, well, we get, what, 4, 1, 1/4, 0, 1/4, 1, 4. Those are the values we get when we square these numbers. And if we write the set of numbers that we get when we square it, it's 0, 1/4, 1, 4. Now this is a set. We don't repeat numbers in a set. There are 4 numbers in this set. If I repeat 1, 4, and 1/4, then I'd have 7 numbers written in there, but there'd still only be 4 numbers in the set. The only numbers in the set are 0, 1/4, 1, and 4. So, this set, this is the range. And the range, of course, is y values. So I've marked the y coordinates of the 7 points, here, 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 and here, the 4 y coordinates that we get in, I guess that's orange. Okay, so domain down here, range up here. Now if we go to the extended basic squaring function, several characteristics. Extended basic squaring function is defined on the interval from -2 to 2, all possible real numbers from -2 to 2, whether we can get an exact value or not, as long as there exists a value, then an x value is in the domain. And there exists no x value between -2 and 2 for which we cannot square it. Okay, we can square any x value at all, especially any x value between -2 and 2. So the domain is going to consist of that entire interval, including -2, indicated by the closed dot, and 2, indicated by this closed dot, and all numbers in between can all be squared. Now we don't go outside of the -2 to 2, okay? We stay within the window of the basic function graph. The y values that we can get when we square numbers between -2 and 2 Well, we can't get a negative number. We can't square anything and get a negative. Well, we can't square any real number and get a negative number. Certainly we can square some imaginary numbers. Any imaginary number squared will give us a negative. That's a different topic, and we'll see that in a few weeks. Okay, so anyhow, squaring the numbers, real numbers from -2 to 2, gives us real numbers no less than 0 and no more than 4, and all numbers from 0 to 4. So as we can see, this graph is nice and continuous from here to here, smooth and continuous, and y values on the graph include 0, include 4, and include all numbers from 0 to 4. That's the range. So the picture of the range is just all the x values that correspond to points in the graph. That's like range. The domain is a set of all the x values that correspond to points in the graph, if I said that wrong. And the range is a set of y values that correspond to all the points in the graph. So, we talked a lot about that. We saw a lot about why that was so, but there it is. The range is a set, the interval, closed interval from 0 to 4. And then the complete basic squaring function is all values, all possible values of x, all real numbers for which the function can be evaluated. Well, no matter what the real number is, whether it's a positive real number or a negative real number, we can square it. It might be a big pain to square if it's a difficult number, but they can all be squared. Okay? We can draw a square that's as wide as that number and as high as that number, and has an area. Okay, that area is the square of the number. For all kinds of reasons, the domain consists of all numbers, all real numbers, approaching negative infinity, approaching infinity. It's an open interval because you can't reach infinity. Infinity is not included, infinity is not a number, infinity is just something you approach. So, there's your domain. The range, well, you can't get a negative number by squaring. Okay, so the range can't consist of any negative numbers. Now you get 0 because you can square 0, and you can get any positive number because, among other things, if you extend the graph, and right here is a picture of the extended graph with the arrows on it. You don't put arrows on this thing, you put closed dots. Okay, on the extended basic function. On the complete basic function, though, you put arrows indicating that this parabola just keeps going and gets steeper and steeper and so forth, following the pattern that you see here. So, there is the graph of the function, and of course, points going up like this, points going up like this are all on the graph as indicated by the arrows. What's the domain? You can square any real number. The domain's negative infinity to infinity, and we do that again in blue by a double arrow on the x-axis indicating the interval. And we indicate a range which consists of all non-negative real numbers by this orange arrow. Okay. There we have domain and range of the basic, extended basic, and complete basic squaring function. The basic exponential function, okay? The domain consists of all the numbers in this set for which you can evaluate the exponential functions. It doesn't include -1/2 or 1/2 because you can't calculate 2 to the 1/2 or 2 to the -1/2. You can approximate it, you can calculate it as accurately as you like, but you never really get it. You never stop. The decimal expansion never stops. No matter how close you are, you can get closer. So you approach the value of like 2 to the 1/2, but you can't ever actually reach it. It exists, but you don't know exactly where it is. Okay, so it's not in the domain of the basic exponential function because you can't write it down. Exactly. You can't locate it exactly on a number line. You can't find its exact value. So there's a domain. You have to exclude -1/2 and 1/2 And all the other values, very easy to do 2 to the x for any of these other values, just very simple. Well, then you get numbers. -2 gives you 1/4, -1 gives you 1/2, 0 gives you 1, and people are still wanting to say that either you can't raise 2 to the 0 power or the 2 to the 0 power is 0. Somebody's not emphasizing the fact, or you're not paying attention. A lot of people are not paying the attention when it is emphasized that any number to the 0 power is 1. Explain why, but it was in the class that's preliminary to the support class that's concurrent with this class. Okay? That's something very fundamental. Anyhow, 2 to the 0 is 1, 2 to the 1 is 2, 2 to the second is 4. Okay, except for the 2 to the 0 equals 1, everybody's probably good with all that. And I don't have time to digress and explain why 2 to the 0 has to be 1. So just accept it. Okay, so the range is all the y values, 1/4, 1/2, 1, 2, and 4. The graph looks like this. The domain, which I didn't write in class, but it's here. -1, -2, -1, 0, 1, and 2. The range is your y values. 1/4, 1/2, 1, 2, and 4. Okay. The extended basic exponential function from -2 to 2, again in the same window, just what we get. We start at this point, draw a smooth curve, and end at this point. Looks like this. And it's clear then that the domain consists of all numbers from -2 to 2. Okay, because we can, even if we can't evaluate it exactly, we know that the value is there somewhere. For any value, for any x value between -2 and 2, plug into 2 to the x, calculate 2 to any of these powers, and there is a result. Okay? And if you do all the numbers from -2 to 2, the values of the basic exponential function follow this curve. So you get all the values from the lowest value here, which is 1/4, up to the highest value, which is 4. So the domain is -2, the interval -2 to 2, closed interval. The range is a closed interval, 1/4, 4. Now for the complete exponential function, you can do 2 to the x for any value of x. If x is a huge negative value, you're going to get the reciprocal of 2 raised to a huge positive value, which is going to be a humongous number. If you divide a humongous number into 1, you get a really tiny number, but you don't get 0. You can't get 0. There's no number that can divide into 1 to give you 0, so that you can't get 0. And if you go to big positive numbers, it's clear that just from the shape of this thing, that you're going to get huge positive numbers. So the range is 0 to infinity.